Welcome to our speakers, Mr. Soutik Nandy and Mr. Jishant Talwar, our Vice Principal, HOD of EXCC Department, Branch Counselor of IEEE-RGIT, Dr. Sanjay Deshmukh Sir, along with the convener of IEEE-RGIT, Dr. Jayant Mahajan Sir, and all the participants present here, to this webinar on automating space exploration using Python, organized by IEEE-RGIT in association with Spaceonova. I, Shreya Jagtap, along with Shalvari Holkar, will be your hosts for this session. Before beginning the session, I would like to introduce you to our renowned speakers. Mr. Soutik Nandy is a Chief Information Technology Officer at Spaceonova. He is an expert in automation and computing. Over the years, he has mastered important skills of Sublime Text, PHP, and Java. He has completed his BTech focused in computer science from International Institute of Information Technology, Bhubaneswar. Introducing our next speaker, Mr. Jishant Talwar. He is the head at the Department of Astronomy and Astrophysics at Spaceonova. He is also the Chief Executive Head at Lumen. Now, I would like to request our branch counselor, Dr. Sanjay Deshmukh Sir, to say a few words.
Okay. Thank you, Shreya. Good evening to one and all. I hope you can hear me, right? Hello. Good evening.
Yes, sir.
Yeah.
Yes, sir, you're audible.
Thank you. Distinguished speakers for the webinar today, Sri Soutik Nandy, the Chief Information Technology Officer, Spaceonova. Mr. Jishant Talwar, Head of the Department of Astronomy and Astrophysics, Spaceonova. Participants, teaching and non-teaching staff of the Institute, IEEE office bearers and Team IEEE-RGIT, and dear students. I welcome you all for this webinar that is organized by IEEE-RGIT in association with Spaceonova on automating space exploration using Python. Dear all, space exploration is one of our interesting topic for many of us actually. And we see there are a lot of companies who are exploring the space. We have heard a lot regarding recently about space tourism and so on. Right, so a lot of happenings are there in this field. For those who are interested to work in this field, I'm sure that this webinar will be definitely a great help. And this is exploration is using Python. Python is one of very popular language, right? So you will learn here about using various tools and libraries in Python to solve various problems in this space technology, I would say. We always encourage the students to work in various disciplines, since we know that research is not related to any specific field as such. And I'm extremely happy, and I should really appreciate our IEEE-RGIT for organizing this webinar. It's a totally different topic. Many of us, many have not touched upon this topic, and it will be a great platform for the students who are participating in this webinar to explore in this field. I offer my best wishes to all the participants, and I once again thank Soutik Nandy and Jishant Talwar for being here with us today. Okay, thank you everyone. Thanks a lot. Over to you.
Thank you so much, sir. All the participants are requested to stay until the end of the webinar, since the instructions about how to obtain the certificates will be given at the end of the session. Now, I further request Mr. Soutik Nandy and Mr. Jishant Talwar to commence the webinar.
Okay, thank you so much, IEEE-RGIT, and thank you so much, Ms. Shreya. Thank you so much, Mr. Sanjay, for the wonderful introduction, for the wonderful beginning of the webinar. And right, the topic is a little bit of interesting because we have automating space exploration and we have Python. So we have extended a few of the good terms for you guys to present or for us to deliver this particular webinar. All right. So let me just quickly present my screen real quick. So, right. So So what we'll do is that we want the chat to be interactive. I want you guys to be interactive. So if you can see my screen perfectly, if my screen is clear, my voice is clear, my audio is clear, if I'm looking good, then please write 1 in the chat section. Else write 0 in the chat section. I'll be monitoring your chat section so as to see that what are the answers which we are getting. Why the numbers 1 and 0? Because in binary terms or in machines normally understand 1 being correct or true and 0 meaning false or not. So that is why we are having ones and zeros, and we will be communicating throughout the webinar using ones and zeros itself. Okay, right down to the very basics. So I can see a lot of ones in the chat section. That is a great way for us to begin this particular webinar, that is automating space exploration using Python. Okay, so first, before actually going on, I'll just take about 30 seconds just to introduce you guys to what Spaceonova is. So Spaceonova has combined 4 qualities into one, which is cosmic, love, innovation, and transformation into together. Okay, so I'll just touch upon on all the 4 very briefly. So cosmic, as you know, that the cosmic has a lot of energy for us. So we want to capture that energy and learn from the cosmic. Love, meaning, as you all know, having respect towards each other. Innovation, well, innovating something new, because that is what in the end we ideally aim for. And transformation, so we want to transform the entire society as well as ourselves. So that is what, if we put all the 4 things together, that is what we at Spaceonova do, where limit tends to infinity. All right, so we have the little maths as well. Okay, so what next I will do is that, as you can see on front of my screen, I've written your network is your net worth. Okay, so your network is your net worth. So what I will do really quick is that I will dedicate a post to IEEE-RGIT and for all of you on my LinkedIn, and I will request every one of you to go over there and just briefly introduce yourself, or that is how we connect each other. Okay, not much, just to name what you do and what you're passionate about. Okay, just a few things. So what I'll do, I'll just quickly move on to there, and there you go. So I'm tagging IEEE-RGIT and Spaceonova, and there you go. I have posted on my LinkedIn. Okay, there you go. I posted on my LinkedIn, and what I'll do is that I'll copy the link and I'll send the same thing on your chat window. Okay, so where's my chat window? I hope I can. You cannot see the chat window. There you go. That's my chat window. Okay, so I have shared the link as well. So that is how we connect with each other, by simply writing your name. Okay, where are you from, or what you're doing, or what you're passionate about. Okay, just a few things, and that is how we can connect with each other. And I'll actually read all the comments whichever I get on this particular post. All right, so I'll be waiting for you guys on this. So till then, you're taking a time for you to write down in the chat section where are you from or what you're doing. So I'll move forward to this particular webinar with the question of why do we use Python? Okay, the first question which almost everyone asks me is why do we use Python? Because there are so many other tools which we can use. Why specifically are you focusing upon Python? Okay, why not some other language? Why are you on Python? So what I'll do, I'll quickly compare different languages in front of you. So what I'm trying to do, I'm trying to display a very simple string in front of you. I'm trying to display a very simple message in front of you, which is hello world. And I will write the same hello world in C++. So as you can see in C++, I'm taking about 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, maybe 5 lines. Okay, so I'm taking about 5 lines to write hello world in C++. Let me do the same thing, but in Java. In Java, how many lines am I taking? I'm taking 1, 2, 3. Okay, let's take 3 lines. Okay, I'm taking 3 lines in Java, 5 lines in C++. Okay, fair enough. So let me just do the same thing in Python. And in Python, how many lines will I take? Well. What I'll do is that I'll quickly open up my Python notebook, or that this is how I run Python commands. And what I'm trying to print hello world. Okay, I'm trying to print hello world on my console. So that is what I'll do. And yeah, that is what I designed. So what more should I write? because this is the answer. So just one single line of writing hello world in Python did the same job as writing 5 lines in C++, 3 lines in Java. I just wrote one simple line in Python and deal done, job done. That is it. That is how fast Python is. Who said Python is slow? Python is not at all slow. It is fast because I can simply write so many words. I think we will be covering all the different questions at the end of the session, right? So I'll take up all the different questions that you have at the end of the session. Okay, you can maybe write down in the chat so that your questions don't get lost or you do not forget them. Okay, I'll take all the questions at the end. So that is why we would use Python. The next question which comes to our mind is, where can we use Python? Okay, you said that Python is really good, it's really fast, but where can I use Python? To be really honest, Python has its application in every domain possible, in every field possible. So let me tweak this question a bit to where can't we use Python? Okay, so that we can get where can't we use Python exactly? Okay, so that we can extract the vulnerabilities and see where can't we use Python. And the answer to that is, wait a minute, what are these brackets? Right, what are these brackets? Okay, I can see that you guys are interested with me and you guys want to scribble with me also, but please refrain from doing that. All right, so where can't we use Python? And the answer to that is nothing but null set. Null set, brackets, what does it mean? Yeah, that means that there is no domain where Python cannot. You name any domain and there are cases where Python can be used, because Python, first of all, is open source, and because of that, many people have contributed in this domain and helped us and created a lot of things on the internet for us to make use of. And that is exactly what we
Hello, I think Soutik is the video. Soutik's video is stuck.
Yeah, his voice also actually. If I'll be able to answer the Python.
I just wanted to ask. Okay, so sir just saw us that you just need to write hello world and it will give the output.
Right.
So I just wanted to say that's the front end of that. So in the back end we need to write some codes for the line. So
yeah,
like how many lines of that code is? So
yes.
C++ we need to write 5 to 6 lines. And so I guess there is some benefit of using Python, like we just need to write 1 line or 2 line code.
Exactly. It's very user friendly. You just write, yeah, You just write the string and it will just give you the output. Or if you want to manipulate something from that string, that you can also do. And if you're talking about the backend, so you don't have to worry about it. Python is already doing that. So that's why it is asked to be, it is said to be very user friendly. So the syntax is very like simple. You just have to write it in English, and that's pretty much about it.
Okay. Thanks.
Yeah, you're welcome.
That is absolutely correct, Jishant. So that is what is the particular use of Python. There's nothing to need in the, there's nothing to write in the backend exactly. Okay, so well, that was on my system. I just suddenly lost internet, but nothing to worry about. I connected on via my phone. Okay, so I'm currently on my phone right now, and I'm trying to join on my laptop. So nevertheless, so that is what exactly happens is you don't need to write anything on the backend then, because Python handles the backend for you. Okay, what you need to do is just you need to simply write one line, and that's all to do. The rest of the things are done or are taken care by Python. So that is what happens. It saves a lot of time, and that is why people tend to say that we or Python is slow, but it is effective, right? You just need to write one simple sentence, and that's it. That is all you need to do. Okay, so I think I am back with my internet connection. Yeah, my internet is now working absolutely fine. So I would be quickly presenting my screen and resuming from where I have. Great. Okay, nevertheless, so I was talking about automating or automating your daily life, because that is what I do. I tend to automate my daily life by writing something or by writing codes or doing or by writing code. Okay, so by writing codes to do the same thing. Okay, I think I have some reverberations. Okay, nevertheless. There you go. That is fantastic. So I would simply automate my life, and that is all, and that is what I was trying to do. Okay, I was trying to automate my life by showing you guys how was I able to automate my life. Okay, so we'll consider a quick scenario. Okay, we'll consider a quick scenario. Just give me one moment, or maybe not. Okay, so right. So what we will particularly be doing right now is I would just simply make about 1,000 folders. Okay, I'm trying to make 1,000 folders, but how would I normally do? I would normally do by writing or by creating one folder and then naming it to one. Then I'll create another folder, name it folder number 2. Then I'll create another folder, name it folder number 3, and then so on and so forth until I reach about 1,000 folders. Don't you think that would be a way too much to do things? Okay.
Right. Soutik, are you sharing your screen?
Right. So don't you think that would be way too much to do things? Okay. By creating or by doing about 1, 2, 3, and so on and so forth. Right. So we will see the same thing how to do it in Python. Okay. So just quickly, moderators, just quickly make me the co-host so that I can resume my screen sharing now that I'm back on. Okay. Right. So I write the code, and you won't believe I would take just 3 lines to write a code for doing the same thing, or that is by making about 1,000 folders. Okay. So let me quickly resume. Right. So what I'll do is that, as I already explained, I normally what I'll do, I'll create one folder, second, third, fourth, fifth, so on and so forth till 1,000. Okay. But is that the correct way to do? Now, Sanju Baba has said no, this means that it is not the right method to do so. So what we'll do is that we'll just do it in not 3, maybe 2 lines. Okay, let's see how. So my first objective is to make one folder. So first what I'll do is I'll make one folder. And how to do that? By writing make folder 1. Okay, I'm just naming it a folder number 1 and just calling it make folder 1. Okay, done. First step accomplished. Second step, making 1000 folders. Okay, so how will I do that? Right now I'm creating one folder which I'm calling it make folder. Okay, that is how I'll create my folders. So how will I create 1000 folders? Maybe some way to do the same thing repeatedly for 1000 times. How will I do so? Well, I'll just write over here a loop. And what does a loop do? Loop will repeat things. So in this case, my loop is going up till 1000, as you can see, and creating folders again and again and again. But they all are being named 1, so 1 is not good. Let me name it I, because over here I'm using I, so it's the same variable I. So I'm just creating folders from 1, 2, 3, 4, 5, 6, 7, 8, 9 till 999, and that is it. My job done. I took 1 and 2. That's it. 2 lines job done. Okay. So how many of you think that, all right, so you have created about 1000 folders in just 2 lines? If you agree with me that yes, this code is absolutely perfect and fantastic and run perfectly and smoothly, then please write 1 in the chat section. If you think, nah, there is something fishy about this code, then write 0 in the chat sections. And let me see how many of you guys believe that this code is absolutely correct, just 2 lines, or 0. Nana, there is something missing in this code which we haven't dealt with. Let me see. Okay, I can see a few ones over here, and okay, okay, just 2 zeros. Okay, most of the people are saying 1 and the rest is saying 0, and the rest of the people who are not writing anything, I can assume that you guys are going with ones, because that is a majority. Okay, so the people who are not writing anything are with ones, so majority believes that this code is absolutely correct. So, and you guys are wrong, because what is make folder? I explained that make folder will create a folder for me. But what is make folder? You know what is a make folder. I know what is make folder, but Python doesn't know what make folder is. Okay, this is a short reference from the movie Total Dhamal. Okay, if you have not watched Total Dhamal, do not watch Total Dhamal. Anyway, so the question arises: what is make folder? Okay, what is make folder? So I have a conversation with me, that is me, obviously, as you can see, so handsome. And this is my Python. Okay. And he's saying, Python is saying that I do not know what make folder is. Can you write that? I mean, can you write the code for that in Python? I'm like, haha, are you mad? I cannot. It's too tough for me. I cannot do that. So then Python comes up and tells me, is it available on the internet so that I can download? So let me bring your attention to this word download. Okay. So download, in other words, also mean nothing but import. So what Python is asking, that is it available on the internet so that I can just simply import it into my into me, or I can simply download that code and make use of that code. I'm like, there is such method, and that is named as mkdir. Now, how would I know it is mkdir? Well, Google. That is the good way to do things. Okay, I could just simply create a new tab. Okay, right. So I can just simply create a new tab, and using that I would do it. So I have my, that is make folder in Python. So let me quickly do a Google search on it. So I'm using DuckDuckGo. If you're using Google, you get the same answer. So as you can say that it's saying something about there is a OS module, and under OS module you have something known as an mkdir. Okay, this is not good enough, but if you're using Google, you can just simply get the first result being saying that it's mkdir. Right, it's os.mkdir. So the function which I'm looking for is mkdir. So what I said in Python that yeah, it's there as mkdir. Then Python says that, do you know the name of the folder so that I can download? Again, I'll bring your attention to this word folder over here. Okay, I bring your attention to this word folder over here. Folder, in other words, also mean module. So what Python is currently asking me is that, do you have that module? Under that module, I'll get the function. So I just want the name of the module. I'm like, yes, it's named as OS. And how will I get that particular function? It is nothing but os.mkdir. Exactly, that is what it says, os.mkdir. That is exactly what I'll do. This was my original code of 2 lines, just writing for I in range 1000, make folder of I. I'll convert it and I'll add one more sentence over here, which is import OS. So I'm just importing OS, or I'm downloading OS. And then over here, I'll simply write OS dot make folder I. But there is no make folder. It's mkdir. So I'll change it to mkdir, which stands for make directory or make folder. So if you shorten it, you get mkdir. And that is all. These 3 lines just save you about, I don't know, how many hours of work. Many hours of work, 3 lines, job done. Again, you don't believe me? Let me show you the same thing on my system. So there you go. I have also imported a few more things so that I can print you how much time did it take. So I'll also show you that this folder currently in front of you, as you can see, is absolutely empty with no files. And now I'll create right in front of you about 1000 files in just 0.75 seconds. That is it, guys. I just created about 1000 files, as you can see, in just 0.75 seconds. That is how quick this is. 0.75 seconds, and that is it. 1000 folders done. This is just one case where I have told you. Want to see other cases? Let's see. So the next case which you're seeing in front of you, this is beautiful. Guys, do you know which thing this is? Okay, can I get some answers in the chat real quick? What this is, what am I currently looking at? This is yellowish, which I can believe. You guys are absolutely right. This is the sun, which we are currently looking at. But obviously, this is what I've taken from the internet, and then, I just imported over here. But no, I have created this particular video or this particular GIF using Python. Okay, I have created that using Python, as you can see over here. It's of 26th of December 2020, and this has been shot by AIA-171 telescope. And as you can see, this is the time. So this has been created using Python. Okay, not render or not, graphically designed. It has been done or created by Python by compiling all the different images which we had. Okay. The next, what we will do is that we will see something which is known as Mars opposition. Okay, well, this does look very dangerous to me, the name Mars opposition. And I believe Jishant would have something more to explain about Mars opposition. Jishant?
Yeah, yes, sure. So it's not very dangerous actually. It's quite simple. I think many of our audience know what actually Mars opposition is, but no worries if you guys don't know. You can clearly see it in the image, right? You can see our favorite sun, our Earth, and Mars. So when all these 3 come in a same straight line, that's when Mars opposition occurs. Okay, so it's basically the problem with our Earth. So it doesn't like seeing Sun and Mars together, right? It doesn't like the relationship of Sun and Mars. So that's why it interferes after every 26 months. So that's not very frequent, but yeah. Mars opposition occurs after every 26 months. That is, it occurred on July 27, 2018. There are some dates on the right that have been mentioned. So 26 months after it occurred on October 13, 2020. And then it will be occurring on December 8, 2022. So I hope you'll be waiting for that to occur. And you can observe Mars very clearly on the day of Mars opposition.
Correct. Yep. So what we will be doing is that, okay, that is absolutely fantastic. But let me actually see the same thing using Python. Let me see how does it look like when other planets are also involved in this particular scenario. Okay, so there I go. I can see a lot of rings over here. Okay, not 7 rings. We have 4 rings. Okay. Ariana is not happy with me, but anyway. So over here you can see we have Mercury, Venus, Earth, and the Mars, and the Sun is over here, the Earth is over here, and the Mars. So you can see a straight line could simply be drawn between these 3 points, and our Mercury and Venus are just in their own world. Similarly, the same thing I can do it in 2020 as well. See, same straight line. and in 2022, which was going to happen again in the same straight line. Not only that, using Python, you can actually predict when Mars opposition will occur. Normally, it's an average of 26 months, but you can also do the same thing using Python and see on which correct dates the Mars opposition is going to happen. All thanks to Python. So that is what we just now saw. But I have a quick riddle for you guys. Okay, it's just 4 words which I've written. When love meets what? Okay, can you guys predict which phenomena I am referring to? When love meets war. I'll give you a hint. It's one opposition which we are dealing with. But which correct opposition am I dealing with? Can I get some answers in the chat which would quench my or which would answer this particular riddle? When love meets war. Okay, I got one answer. Okay, it's two answers. We have two answers, which is Venus and Mars, and Earth and Mars. Okay, so we have two of them, Venus and Mars, Earth and Mars. But we just saw Earth and Mars opposition, right? So there must be something else, some other planets which we are dealing with. Okay, and yes, Aryaman, you are right. We are dealing with opposition of Venus and Mars. Where Venus is the planet of love, and Mars is a planet of war, which, as you can see by the colors indicated, blue and red. But wait a minute. Mercury, Venus, Earth, Mars. Then how is Venus and Mars opposing? Because Earth is in the middle and Sun is right over here. How is this opposition occurring? How is it occurring? I'm so confused. Let me do it using Python and let's see how exactly this opposition occurs. Okay, because Venus is over here, Earth is over here, Mars is over here. So they're like three different things. So how are they opposing? We don't know. So let me see it using Python and let's see how they look like. So before we that, we have a beautiful picture of our lovely Mars, which is in reddish color, as you can see, and Venus shining so brightly. And this was taken very recently. The date of this was on 13th of September. Okay, not
No,
September,
July,
13th of July. 13th
Yeah.
of July. 13th of July, this opposition occurs. So just 2 months? Yeah, just 2 months ago this happened. So I'm pretty sure most of you have captured this particular image because it is rare. This happens very rarely. Okay, so but again, my question is not answered. How is this? Oh, okay. This is our Earth, this is our Venus, and that is our Mars. And they are in the same straight line. Okay, that is genius and that is very rare. I'm definitely sure. This is very rare to happen. And honestly, even I was also confused that how is Venus and Mars opposing with Earth? I mean, they're like so different from each other. Okay, how are they opposing? And that is how I can see how are they opposing. Let me see the same thing. Conjunction is the word. Thank you so much, Sheikh. Conjunction was the word. My bad. Conjunction was the word we are looking at. This is Venus and Mars conjunction. Absolutely correct. So again, this happened in 2021, just 2 months back. The next Venus Mars conjunction will happen in 2034. Okay, again, get your cameras ready, mark this date, make a reminder to capture Venus and Mars on 2034, May 11th. 11th of May 2034. Again, they will in the same straight line as you can see. It's just beautiful. It's just beautiful. And thanks to that, I can actually see how are they in the same straight line. The next what we are going to be dealing with is cannonball experiment. Okay, again, this is a very dangerous experiment, so do not try this at home. All right?
Yeah. Under the guidance of parents.
Not even under the guidance.
All right.
So, Jishant,
Okay.
I think you like to give more insights about
Yeah.
the cannonball
So,
experiment.
yeah. So, like, all of you know about Newton, right? Right. Okay, we can do a poll. You can write one in the chat section if you guys know what Newton is, or who Newton is.
Okay, who Newton is? Right, one is 0. So,
Apple
Apple guy.
Steve Jobs.
That is not Steve Jobs, it is Newton. Okay.
Yeah.
Now I'm getting the ones right now.
Yeah. Actually, I was talking about Rajkumar Rao's movie, but yeah, never mind. All right. So yeah, we all know who Newton is, and all his contributions to the world of physics and science. Okay, so you guys have heard of that apple guy when he was sitting under a tree and an apple fall on his head. So that's why he wondered, that's how, and that's when he wondered that things are falling towards the center of the earth, right? Towards the surface or the center of the earth. And that's when he wondered that why not moon is falling towards the earth? Why not they both are colliding? So he hypothesized a thought experiment. So he thought that let's take a cannon, okay, and climb onto a huge mountain, a tall mountain, the tallest mountain you can find in the world, and put the cannon there. And then you put a cannonball, light up the fire, and boom, okay, the cannonball is thrown out of the cannon. Now, if it is thrown with comparatively lesser velocity, it will reach point A, right? So what Newton did, he increased the velocity, increased the gunpowder and all that stuff. Then he boomed that cannonball out, and then it reached the point B, right? And a time came, yeah, I'm talking about the thought experiment. I'll just mention that was not the actual experiment he did. So then what he did, he again tried to increase the velocity, and a time came when the forces balanced out, right? When the gravitational force of the gravitational force of attraction of the earth was canceling out with the force acting outwards, right? The centrifugal force. So that's when the cannonball came in an orbit around the earth, right? But Newton didn't stop here. So he tried to increase the velocity, and that's how he increased the orbit of the what you can say, of the cannonball, okay? And a time came when this cannonball escaped the gravitational influence of the earth. That's what Siddhant said, escape velocity. So whenever it escapes the gravitational velocity of the earth, gravitational attraction of the earth, that's when it is moving with escape velocity, that is 11.2 kilometers per second for the earth. Yep. So this was about the cannonball experiment. But now let's try to visualize this using Python, all the cases that we have understood. So let's try to visualize it using Python.
Definitely. So again, this stunt was not performed with any cannon or volcano or a ball. Okay, thought experiment. Okay, so that is why I said do not try this at home. You can try it out in your minds, but not in reality.
Yeah.
Or using Python, I'll also allow that as well. So what we are currently doing is that I have a rocket and I fired it at 3 kilometers per second. So it went zoom, boom, finished. But what if I at 8 kilometers per second? It revolves around the Earth. Let me give it a little more velocity, 10 kilometers per second. And as you can see, it revolves around the Earth in a highly elliptical orbit. And trust me, I never knew that if you fire at 8 or 10, I believe that it must be, just crashing somewhere. But taking a complete revolution around the Earth, that is something huge. Okay, 8 kilometers, wow. 10 kilometers, fantastic. 12 kilometers, so whoosh. That is what is your escape velocity, 11.2. So I give it much more, 12 kilometers per second. As you can see, it simply escaped the gravitational pull of the Earth. Now it is going in a very high elliptical orbit. Okay, so this was nice. This is very nice. This is nice to the next level. Okay, so that all the 4 things, you can do it. You can simulate them using Python. You can play around with the code, fiddle a few more values, given somewhere 5, 6, 7. Then let's see in which country does it bombard. Okay, again using Python, not in real life. Anyway. So the next, which we are seeing right now in front of you, is Orion, but in 3D. Okay, so before I move on to the 3D part, I have the Orion part being explained by Jishant.
All right. So Orion, like many of you must have heard, it's a very famous constellation. Okay. So this Orion constellation, it is very easy to spot in the night sky, basically. So I'm sorry for the people who are living in Delhi or in regions where there's too much of light pollution, But yeah, you can go to some hilly regions or some regions where there's less light. You can easily spot that. I also spotted it in Shimla, but I live in Delhi, unfortunately. Okay. So to spot this Orion constellation, you just have to look for this Orion's belt, right? These three stars. You just spot them, and then you can connect the dots to form the whole constellation. All right, it was visible in Surat. Awesome. Okay, so if I move from left to right, these three stars are Alnitak, Alnilam, and Mintaka, right? And towards the upper left, we have Betelgeuse. Yeah, Betelgeuse. And in parallel to that, yeah, we have the Bellatrix. Yeah, Bellatrix. Towards the bottom left, we have Saiph, and then there's Rigel. All right. So this Orion constellation, there's a story behind it. Why is it called Orion, right? It's the Orion basically means the hunter, right? And you can see that it is trying to hunt the Pleiades constellation, right? This constellation is also called as the Seven Sisters. So it is trying to hunt the Pleiades, and it's like it is pulling the arrow and just waiting for it to shoot out. So trying to hunt the Pleiades, and that's why it is called as hunter. Yeah, Greek myth. So that's how they recognize the pattern, the Greek astronomers and ancient people. That's why they named it Orion. All right. So I have a question for you all. Let's say, okay, just imagine, you sit in an aircraft. Oh, I'm sorry, spacecraft, and then travel to some other place in the universe. Let's say to the Earth 2.0. Okay, it's far away from the actual Earth, and is somewhere lying in the universe. And then you try to look at the stars of this Orion constellation, right? So I have a question for you all. Okay, should we take the poll, Soutik, right now, or yeah, I think we should. Yeah. Okay. So I have a question for you all, that will the pattern of the Orion constellation change? If yes, write 0 in the chat section. If no, write 1 in the chat section. It's quite complex. No, 1, yes, 0.
Okay, maybe if you're saying that, will the constellation remain the same, then write 1.
Right.
Else write 0 in the chat section. Okay, if you think that nah, it will be something else. It will no longer be Orion.
Yeah, we have mix of zeros and ones actually.
Okay, so we have mixes of zeros and ones. Great. So, okay, I love this curiosity. So, what I'll do is that I'll take this same constellation. Okay, but as Jishant said, we're moving on to Earth 2.0. I'll actually move on to some place very close to Orion, and maybe just from top or maybe from below me, something near that. I wanna visualize this Orion. Okay, so what I'll first do is I'll first plot the markings which we have X, Y, and Z coordinates, and then there you go. These are the different points right in front of me. So the 3 stars in a hunter position. Right. I think I can spot them. Yeah, there it is. No, it's not there. Oh no, right? Oh, wait, I cannot find them. I cannot get my Orion. And that is your answer. However, you try to revolve or rotate this particular graph and try to see where this Orion is, you cannot get the 3 stars or the belt and then form the rest, because you cannot get the constellation in front of it. And the reason for that is actually quite beautiful. Why we cannot get this Orion, why can't we get this, is because so what happens exactly is, because of the location of Earth in this universe and the location of the stars and where we are currently locating, and the curvature of the Earth makes the Orion visible to us. So you all should be grateful living on this beautiful planet Earth, because if we were somewhere other, if we were in some other planet, then spotting this Orion, the same Orion, is not possible at all. You will not get the same Orion as on Earth. So be grateful living on this beautiful planet Earth. And that is what is over here. The visualization does not curve as the night sky does. There is beauty in the location of the Earth and understanding of the Earth perspective. We see the shape of the Orion because of the Earth's location and the location of the stars in the constellation. Okay, so grateful and living on this beautiful planet Earth and seeing such beautiful stars. So next, I can see that is that ISS. Okay, is that ISS? And yes, that is the ISS. So Jishant, quickly on ISS.
Yeah, sure. Like it's nothing to talk about, but yeah, ISS is International Space Station. All of you must be knowing that. Okay, so it's a habitable artificial satellite, right? It's revolving around the Earth around 400 kilometers above the surface in the lower Earth orbit. So the basic purpose of the International Space Station was initially to act as a checkpoint, right? Let's say you are traveling from Earth to Moon. Yeah, Moon is very far actually. And if you are traveling from Earth to Mars, that is really very far. So it would be very difficult to carry all those resources and all that stuff and without having a checkpoint. So ISS would act as a checkpoint for you, and then you can travel to some other point in the universe. But with time, it was also recognized that ISS can be used for research purpose, for us to understand the cosmic nature of the universe. So for that, it has been used for various research purposes, like for microgravity, and some of the biological experiments have also been done, how life evolves. Even the humans that live here are there for experiments are being conducted on themselves actually. So yeah, that's what all is going on in the ISS.
Okay, so again, it's ISS. Okay, yeah. Next, so what I'll be doing is, as you all know, that as Jishant said, I mean, the focus is on the various parts of our planet Earth. So we want to see that where exactly this ISS is currently. And to do that, I just quickly run the cell and we can see where this ISS is located. There you go. It is somewhere in this Russia, right? It's currently in Russia, and a few moments later, it will somewhere over here, then somewhere over here, and then again start from America, and that is how this would go on. If you don't believe me, check out the current location of ISS and then come back to me and then see that we get the same answers or not. So as you can see, the latitude and longitude has slightly changed, and it's slightly in the water now rather than on the land. Okay, that's slightly moved into the water region. So that is what you can see, that the ISS keeps on moving slowly and slowly. That's what we would be seeing. The next interesting, and this is my personal favorite, is double pendulum. Okay, so what exactly is double pendulum? Let me give you a hint. It has two pendulums, ergo double pendulum. But these pendulums are somewhere attached just below the other. We have one pendulum, and just below that we have another pendulum. So that is what is double pendulum. I'm sure you must have not seen, and oh wow, holy wow, that is some beautiful simulation going on. So if you see that this is just one pendulum, and just below that we have another pendulum, and the reason why this cannot be conducted in real life, because friction, gravity, and how can you just conduct two pendulums just below the other and make them or just give them a slight disturbance, and that is what they will continuously happen. Okay, this is very difficult to see in real life, but just because thanks to Python and the simulations, you can see the trajectory is quite unpredictable. And if you see, this is the pivot point, but at some points, the second pendulum will simply go and overtake that pivot right there, which happened. Okay, it simply overtook that, and that is something beautiful. And also, the first pendulum would rise above the level of the pivot. That is another great observation of this double pendulum. And see, it rose above that pivot. Okay, I mean, there is this beautiful nature of this unpredictability, of this randomness. You can see how beautiful this randomness also is. And thanks to Python, we can see this simulation. And in real life, it is not impossible, but you can create, but it is way simpler in Python, you can see. Now, if you can change the masses of them, this is now 1 kg, 1 kg. If you change the mass, the trajectory will quickly change and would just completely be different. If you make one lighter, one heavier, then the trajectory would be, I don't know, it would be interesting to watch. Okay. And if you change the mass of the first one and the change mass of the second one, again, it will be more interesting to watch. Okay, that's up to you how interesting you want to make and fiddle around with the code and see what the trajectory is, draw conclusions from them. That is exactly what our main intention is. Okay. So now enough of these things. We want some good content. So right now I have 18 plus content. I believe everyone is 18 plus. So I can quickly move on to integration, which is everyone's favorite and with people who are only above 18 can do. So I have a quick brief or a quick recap of integration. Integration x squared dx. What is integration x squared dx? No one could help me. Oh, I have x cubed by 3. Correct. So I have x cubed by 3. And I believe everyone would support that. Yes, it is x cubed by 3. Right? Okay, so I'm right. Okay. So you guys are okay. You guys are taking time just to make the superscript. All right, fantastic. Fantastic, everyone. You guys are absolutely correct. Okay, plus 1 plus c. Great. And now solve this for integration time. 6 together. This. Okay, obviously this is not easy to solve because you need to do substitution and the same thing, but how about I tell you I can do the same thing in Python in just 4 lines. Okay, right. So the first 2 lines are importing of my modules. Third line I'm just creating a variable x. Fourth line I'm integrating tan inverse x divided by 1 by 1 plus x squared. There you go, that is your answer. X tan inverse x minus log of x squared plus 1 by 2 minus tan inverse x whole square by 2. Okay, you want to do it with limits from 0 to infinity ln x divided by 1 plus x squared. Again, you can do the same thing by just writing ln x divided by 1 plus x squared. X from 0 to infinity. Okay, what are these 2 zeros? 2 zeros, if you bring together, they kind of look like infinity symbol. That is what it is currently. If you write 0, 0, as you can see, it becomes your infinity symbol. And an integration of this is, let's say, how much time does it take? And okay, I forgot to run this particular cell. There you go. Right, and there you go. Down. And the integration of this is nothing but 0. That is it. That is how quick your integration happens. So zoom, boom, done. That's finished. That is how quick your integration is. So if you want to do all your different assignments, check the answer. That is how you should do. You can just simply do the integration, differentiation, left-hand limit, right-hand limit. Everything is possible using Python. Right? That is how quick things are. So let me now move on to a more interesting concept, which is pulsar and hidden pulsar. So now what exactly are pulsars? So guys, if you heard of the word pulsar, then please write 1 in the chat section. If you have not heard the word pulsar, write 0 in the chat section. So let me see if you have heard about pulsar or not. Okay, I have a mix of zeros and I have a mix of ones. So right, over to you, Jishant, for what pulsars are.
So what do you guys think what pulsar is? So what are we actually talking about?
Fastest objects. I hope. I mean, is it faster than the sun? I don't think so. But okay, fastest objects. Lightning McQueen. We have a new Lightning McQueen right in front of us. Stars. Okay, pulsars are stars. Any other answers, guys? Just few keywords. That is it. Electromagnetic stars. Neutron stars are rotate extremely fast. Okay. Yep. Okay. Then we have plus 1. Gamma burst. Okay. Just write plus 1. So it's not correct for that. Plus 1. Gamma burst. Okay. And I regret to inform you guys are all wrong. No, right. This is a pulsar. Yeah, there you go. Winner is
we have the winner.
Yes, winner, you have won this competition, and this is a pulsar which we are talking correctly about. But yeah, keeping jokes apart,
yeah, this beautiful thing you see right here is a pulsar. So who answered that? I think Aryaman. Yeah, so pulsars are basically rotating neutron stars, right? And they pulse, as you can see these pulses. They pulse because they rotate, right? And what are these pulses? These pulses are the jets of radiation. Okay, these are the jets of radiation which are emitted by the magnetic poles of the neutron star through various processes that are going on there. Okay, various radiation processes are going on, like synchrotron radiation or inverse Compton scattering. Yeah, these are the two major ones that are being occurring. So because of that, you can see these pulses. Now, the behavior of this neutron star is very analogous to what we see in case of a lighthouse. Yeah. So it's very similar. You can see actually the beam of radiation is there in case of a lighthouse as well, and same is with the pulsar. Okay, and if you look carefully, that this beam of radiation, right, it sweeps around the eye of the observer, right? Our eye, we are observing in case of a lighthouse, and in case of a neutron star, it is the telescope that through which we are observing. So this beam of radiation, it sweeps around the eye of the observer, and it has a certain periodicity associated with it, right? In case of a lighthouse, it does so after every 5 seconds, right? 1, 2, 3, 4, and 5, right? Okay, so after every 5 seconds, this beam of radiation is pointing towards us, right? In case of a pulsar, like, they can be periodic as well as aperiodic, and many of them that we see are quite periodic. Okay, and they can go as high as, the periodicity can go as high as like up to years as well, but the smallest, yeah, but the smallest periodicity that we have seen is 0.001 seconds. That is 1 milliseconds. Yeah, 1 millisecond would be good. Yeah. So 1 milliseconds is the time that we have seen for the periodicity of a neutron star. So you can imagine how fast they are rotating. Okay. After every 1 second, this pulse is pointing towards us. So that's how fast they are rotating. Now, if I talk about the detection of the pulsar, yeah, so you can only detect a pulsar when the pulse is pointing towards you. When it is pointing in some other direction, you cannot detect it. Okay, this is why, because let me give you a comparison between the sun and this neutron star. Right, sun has a radius of 696,000 kilometers approximately. Okay, whereas for a neutron star, the radius is just 10 kilometers. Okay, that for a star to be of 10 kilometers, it's like you cannot regard it as a star, but yeah, actually it is a 10-kilometer radius. That's like a city in India, basically, with a 10-kilometer radius. So to detect an object which is of radius 10 kilometers and millions of light years away from us would be like very difficult, impossible actually. But we can do so using the pulses. Yes, you can know about its existence and behavior only by the pulses. Okay, so what kind of signal we get through this neutron star? Ideally, the signal should look like the one on the upper left, right? The pulse is coming towards us. Okay, at a certain point, when the amplitude is maximum, the pulse is directly pointing towards us, right? And then it goes in in the other direction. Okay, so this should be the ideal case of the radiation. But what actually we get, yeah, Soutik is enjoying that signal. Okay, but what actually we get is this mess of radiation. Okay, there's too much of noise is there in this image, right? There's too much of noise. So what do we actually do to remove this noise is, you get a lot of signals, right? Let's say we take a lot of images of the pulsar, and then there's too much of noise in there, right? So what do we do? Noise is basically anything like light from the sun or other interstellar gas, the dust in the cloud, the scattering of light, all that is taking place. So that will contribute to the noise. And this noise is just random. Okay, so what do we do? It has positive and negative values. So what we do, we take a lot of images, we take a lot of signals, and then stack them together. As I said, noise is random. So many of the positive values will get cancelled out with negative values and so on. forth. So that's how the signal will start to appear in the actual signal will start to appear in the signal that you are getting, as you can see on the bottom right. Okay, you can see the resemblance of actual signal, that how it should be. Okay, if you stack more and more signals, more and more images, then you'll get close to the ideal signal what we actually should be getting for a pulsar. I think we should move on to Python to actually find the hidden pulsars. Okay, they must be confused what signal is, what image is, and all that stuff. So let's try to visualize that.
Exactly. So what Jishant actually said is, a pulsar, it just, revolves, and somewhere or the other, it points towards you and then moves away from you. Just imagine you sitting here with your camera, right? Just trying to click these pictures, but you don't know when it is pointing towards you and when it is not pointing towards you. You do not take that risk. You don't know the periodicity. So what we would do is sit with the camera and just take on pictures and pictures and pictures and pictures and pictures, and then they'll hand it over to me for finding out where this pulsar is. Okay, that is exactly what we will do. So let me just move on to my hidden pulsars. And right, I have about 1000 fixed file. Okay, my favorite number. So I have about 1000 fixed file. And what I will do is I'll actually make it very simple for you guys. What I'll do is that I'll extract the data of every image into one. I'll just simply extract 1, 1, 1, 1. And like this, I will extract 1000 images. Okay, I'll extract the data of 1000 images and then put them into one sort of bucket or one sort of collection. Then I'll just take the mean of all the different images which I have to get my final answer. Along with mean, I'll also find out my median as well. Okay, so that I can get both the answers. I will find out the mean as well as my median. Okay, I find out both of them. I'll find my median and the mean of different 1000 images, and then I'll plot my final result right in front of you. So what I have already done is I have already detected the data, or I have collected the data of 1000 bits file, and I've stored it nice and safe. And then I'm creating another object by taking the median as well as the mean. Okay, I'm taking the mean as well as the median, and then I'm plotting my final results. Along with that, I'm also plotting two random images, which is 241 and 973. But wait, you don't believe me or you don't trust me that it is random or not. So what I want is I want 6 people to just write one number from 1 to 9. Just write one number each, and I'll quickly take out the top 6 numbers. Okay, just write one number. I have 7 for now. I have another 7. I have 6.
Another 6.
I have 6 and 667. Okay, so you guys have taken very nice numbers. So I have image number 776 and I have image number 667. I have 2. I have image number 776 and I have image number 667. And then let me plot those results real quick. Okay, it's fine. Anyway, so this is my random image number 776. Not a good image, guys. I cannot see the pulsar of this. It is very, as you can see that it has a bit of noise and going 1.6 and it's very darkish. Not a good image. Then I have 667. Okay, still not a good image. There is no pulsar. Pulsar where? Then I'll come back to my stack image. There is the pulsar. Right. So things we should note from this is the pulsar has its intensity of 0.03. That is how feeble it is. And over here, it's going up to 0.8. And over here, it is going up to 1.6. So can you guys assume 0.03? It will be lost among all the different noises and stars, putting in dominance. And this cute little pulsar of 0.03 is not able to shine at all. Thanks to our stacking, what we did together and we took out the mean. Okay, but in this particular case, what you're seeing in front of you is the median, not the mean. It's the median. I stacked and I've used my median to get my final result, and this is what is my result and looking like. And as you can see, how beautiful this image is, and this pulsar is very clearly visible to us. Okay, it is very clearly visible to us that right there is our pulsar. That is what is a pulsar, which I was not able to find out from this image or from this image, but only from this particular image. Okay. So, right. So with this, we have come to the last part of this particular webinar, and I want you guys to help me and figure out which game am I referring to. Okay. Come on, guys, quick. We're running out of time. Which game? Among Us. You guys are absolutely correct. This is the famous game Among Us, which everyone of us have played. Those of you who have not played, yes, us. You use us, not me. Use us. Okay. So this particular thing which you're currently seeing in front of you has been created again using Python. You don't believe me? I know you won't believe me. So that is why I bring you the illustration right in front of you. I'll illustrate this particular thing. If you see over here, there you go. This is the cursor currently, and I'll create that same Among Us character. Okay, so, okay, my bad. There it is. There you go. So, voila. So, want to see it again? Okay, I'll just actually show you again because we might have missed it. So, there you go. Right. So, where it is? Right. There is my. Okay. It's not showing anyway. So, I'll just again quickly present there. So, there you go again. Ta-da! So that is okay. You guys, red sus. I saw red went, but anyway. So that was the Among Us, and with this we have actually come to the end of this particular session, and now it's time for the crowd query. So thank you for your time, guys, and everyone. I hope I'll see you all live, which you are currently live, and also see you all alive. Okay, that is also very important. Take care of your health, everyone, and stay safe in this pandemic. Okay, see you live and live. So over to you, Shravali. You're mute, so I think your voice is not.
Okay, sorry. Yeah. So thank you, sir, for such an insightful session. Now heading towards the question and answer session. So participants who are here in the Zoom are requested to raise their hand to ask the questions, and you can unmute once we call out your name. And participants attending the session from YouTube Live can put the question in live chat and we'll address them. So now first question we'll take is from a live chat by Sakshi Magare. So does VR play key role in space exploration? And if no, then does it have the potential?
Okay, so VR, right? Okay, yeah. So okay, first of all, that is something which is obviously everyone is working upon VR and AR, which is virtual reality, as you all know. So virtual reality, actually, yes, our main goal is for everyone to understand space, everyone to understand universe, everyone to understand how it looks like from the earthly's perspective, not from the earthly's perspective, some other perspective, and somewhere or the other, we are definitely working towards VR, and there are a lot of, there are a lot of people who are working towards this cause of virtual reality and creating something or the other for us to explore. And yes, virtual reality is the next, I don't know how many years. It's not so far. It's not 10 or 20 years down the lane. It's just hardly 3 to 5 years down the lane, and you will have your VR headsets, and you can simply see the entire universe right sitting in front of the screen, or right sitting in your house and see the entire universe.
So thank you so much, sir, for such a detailed explanation. So next question will take also from YouTube live chat, and it's from Yavar. Are there any other interesting events that occur due to major events like Mars opposition?
Jishant, I think you can explain this.
Are there any?
Are there any other interesting events that
Yeah.
occur due to major events like Mars opposition?
Yes, there are a lot of events that you can observe from Earth and then analyze it using Python. And even the events that you cannot observe from the Earth, you can actually simulate and visualize that event, like merge of two galaxies, or let's say explosion of a star, or um, how the universe expanded during the Big Bang, right? All of these amazing stuff you can visualize using Python, and it has such a broad application in space.
Yes, sir. Thank you so much. Okay, the next question is from Zoom chat from Aryaman. Which library should someone start with for exploring this aspect of programming? Also, any resources you would recommend?
Astroby.
Right. So, Aryaman, this exactly, or this module which you are asking about for this particular aspect of programming, it would be AstroPy, which is your tagline, Jishant.
Right, a community Python library for astronomy and made by the astronomers for the astronomers. Yeah,
Exactly. So AstroPy is something which you would start to work upon because it has tons of things, and I have currently used AstroPy for dealing with different sets of images. So any resources, well, you can obviously go ahead and look out for the various resources that you're asking for. But the first thing which I would recommend is the documentation of AstroPy. The documentation itself is quite detailed and it has a lot of examples, tutorials, something or the other, which you can definitely explore. And in case you want more assistance or something or the other, simply connect with me on LinkedIn. Okay. I think I will help you out for furthermore in detail about AstroPy and exactly how things work. Okay. But feel free to explore yourself.
Thank you so much. So the next question we have is from YT Live Chat from Anush. Does Python language play a key role in helping build space infrastructure as well, or is it too soon for the current technological advancement?
Okay. Well, technological infrastructure, if you're asking, okay. So to be honest, the Python, you can actually build something or the other using Python, not only using Python, using any other programming language. A simple example, if I want to give you, I would give you an example of a rover. Okay, you can simply make a rover and you can program it using Python. Okay, you can make sure to code it in a manner so that your rover is self-sufficient on any other extraterrestrial surface where they can survive on their own. Okay, that is just one case that I explained, but this is just one scenario. Other scenarios would be most upon your which it is mostly on research. And yes, research can give you more insights or the other, but there is one such application where it is not particularly research but self-sustainability in the space world, or anything which you want minimum human interaction. I mean, in the end, space is something about minimal human interference, because as you know, how much time does it take from this earth ground station for the signals to reach over there, right? By the time you keep this left turn, it has already fallen on the pit. Okay, so that is why you need anything, or you want to code it in a manner which is self-sufficient. That is why not only Python, any programming language you can take.
Okay, thank you, sir. So now I can see Jugal Chawda raising his hand. So we'll take his question. Yeah, Jugal, you can unmute yourself and ask the question.
Yeah. Hi, Jishant. Hi, Soutik. My question is, what is your take on commercialization of Mars, and how has it changed the space exploration technology, and how it will change in future? Like everything is getting capitalized now. It's not just nationwide; it's booming. So, what is your take on that?
Quickly buy a plot on Mars. Okay, that's the first thing you will do. Okay, Jugal. But
Sorry?
Buy a plot for yourself so that you can create your house on Mars. Anyway.
Surely. One day I will.
Jishant, I think you can also do it.
Yeah, so Soutik had given you a very great idea, but yeah, the Mars industry, in the field of Mars, like there's been too much of exploration, and there's too much of research on geology, and recently the rover has been launched, Perseverance. So actually there's too much of research going on Mars, and we are aiming, the space industry is basically aiming for that to be another Earth where humans can survive. But it will generally actually take a lot of time for us to do so. And the research is going on in terms of geology, the environment, and all that stuff, for trying to understand how fit will it be for humans, right? And I think it has a great scope in future, and I definitely like support Elon Musk and others who are trying to do so. So yeah, that's it.
Yeah, thank you, sir. So now the next question is from YT live chat by Pratik. So can you name some popular programming algorithms that are used in space exploration?
Okay, so popular algorithms used in space exploration. All right. To be you can actually, I mean, okay, so first thing is that there is no such algorithm which I'm currently crossing my mind. Okay, but to be honest, it's not more algorithm. It's basically you develop an algorithm. Okay,
Right.
you take in a few of the existing algorithms, any maybe you can take in any crystals algorithm or any such algorithm, and then you implement in a manner so that it fits the space industry. Okay, there is no ready-made algorithm available as such. You need to create all those different algorithms specific to your need. Okay, that is what happens, and there are people who are developing such algorithms constantly based upon their need. Okay, but I don't think it is named as such. Jishant, is there anything which is named as such, or
Yeah, I don't think there is. Like, it depends on the need of where you want to implement the Python and any other programming language. Yep. So you actually design it based on your needs.
yeah? So there is no name given to any algorithm, but the algorithms are constantly being developed based upon their need. Okay, if you want an algorithm for doing something, maybe spotting of an asteroid, the algorithm would be named asteroid spotter. I'm just giving it name of any algorithm. Okay, so that is how it is. I hope I've answered your question, Pratik.
Yeah, sir. Thank you so much. So the next question is by Parag in a Zoom chat. Can we create 3D matrix of space-time?
Yes, you can, but that would require a larger computation for that. Like a normal computer would give you a satisfying result. Yeah, space-time actually isn't 3D, it's 4D. So it would be very difficult for you to make in Python or even visualize if you come out with a space-time matrix or anything, space-time visualization even in Python. So it would be very difficult, but I think at some point we would be able to do so. But for that, you would require a larger computation, large power to give you to your computer. Maybe quantum computers are coming ahead for you to work on.
Not exactly space time, but I think you can simulate something of happenings in space, right,
Right.
Rishabh? Not
Yes,
exactly
yes,
space
definitely
time.
you can. Yeah.
You can do 3D visualization of the various things in happening in space, but not this matrix of space time.
Yeah.
As of
Like not in a great detail, as like depends upon your imagination. How would you want it to be? Like properly Minkowski space and all that stuff you want to simulate, that would yeah, definitely require a larger computation. But you can do so to a shorter extent to get a good visualization in 2D basically for that 4D space time.
Okay, thank you, sir. So I can see Sheikh has raised his hand. So yeah, Sheikh, you can unmute yourself and ask your question.
Okay, good evening, everyone. As we know that we are really doing very well in space exploration, but actually, really, is it worth of that? That means, are we able to apply those things in day-to-day life? Like, what are we are exploring is really helpful for us in day-to-day life or not?
Right. Shall I answer that? Sheikh, do you know Wi-Fi?
Yeah.
Yeah, so the Wi-Fi that we actually use, like the internet, and even in the field of biology, have you heard of X-rays, right?
Yeah.
So all of the things that we have gained so far is only by space exploration. Okay, the signal Wi-Fi, basically, it contributes. It actually, what can I say? The Fourier transform, you must have heard of, maybe the fast Fourier transform. Yeah, it uses that concept to like merge of combining all the radio signals and all that stuff. And we have come with an idea for a Wi-Fi after the space exploration, when we have heard of some of the radio sources that we have. The radio astronomy has evolved then. And similarly, as I said, X-rays. So there are awesome X-ray sources in the universe which are like really beautiful, and exploring that has helped us gaining all of these technologies.
Actually, my question is that we are exploring black holes, neutron stars, pulsars, etc. We are studying everything. They are useful to us?
Yes, they are. Like, I'll give you another example. Okay,
Yeah.
Let's say you are studying pulsars, that we already did, right?
Yeah.
Now, what is the point of studying pulsar is, you know about different radiation processes. You believe in that understanding, like the radiation processes, like black body radiation.
Yeah.
Right? Yeah. You believe in that?
Yeah.
So if you want to know how fundamentally it began and how actually all of the universe started, you have to look at these things.
I mean, is it just for study, or is any day-to-day life use of those
Sheikh,
things?
I'll give you a very day-to-day life example. Okay.
Yeah.
You're living on this planet Earth. Okay.
Yeah.
Eventually, the sun will expand and engulf Earth. Okay.
Yeah.
Where will you go? To answer that question, we are doing space exploration in the search of any viable planet where we can. That is the ultimate aim which we are looking for.
Okay.
Not right now, building centuries ahead, we are looking for that answer right now, because somewhere or the other, we know that the end is inevitable, but can we avoid that end and move on somewhere else, start a new universe? That is the answer.
Actually, once an old man asked me about this, I also gave that same answer. I just want to verify that is it right or not.
It's absolutely right.
That is why we're looking for alternative power source. To be more formal, we're looking for alternative power source. That is it.
Thank you very much.
Yeah, thank you, sir. So lastly, Mukesh is asking in chat box if we could share the Jupyter file.
Mukesh, I mean, I do not have any problem in sharing them, but I want you guys to create it on your own. Okay. I want you guys to learn Python, to understand, to move on, read documentation, and do the same things what I have done. But you alone would do it. There's no fun in giving up. Okay, there's no fun. You just simply run it. That's it. But there is fun if you develop it. Okay. And in case of any queries, I'm actually just a text away. Okay, I'm just actually a text away, either on LinkedIn or Discord or email, anywhere. Okay, and I would be definitely glad to help you all. Okay.
Thank you so much, sir. And thank you both of you for such an informative question and answer session. So now I would like to request the branch convener of IEEE-RGIT, Dr. Jayant Mahajan, sir, to give the vote of thanks.
Okay, myself is Dr. Jayant Mahajan. I am the branch convener of this IEEE-RGIT. Are you hear me?
Yes, sir.
Okay. On behalf of the whole committee, IEEE-RGIT, I would like to thank Spaceonova, Mr. Soutik, Nandy, and Mr. Jishant, Talwar for sparing your valuable time and inspiring us with their knowledge about space exploration. We are extremely grateful to you for giving us an insight on how the role of coding and data science in space works. Application on Mars position using programming, Newton, pulsars, and many more. This has truly been an inspiring and encouraging session for the participants. Last but not the least, thank you to the audience for being so cooperative and staying tuned throughout the evening and making the most out of it. Thank you, all of you.
Thank you, sir. So now I request all the participants to please fill the feedback form to obtain the certificates, and the link for which is posted in the chat box. So for any further queries regarding the certificates, please refer the official WhatsApp. Thank you.
Thank you. Thank you so much. The webinar has ended and the participants can leave. And yeah, that's it mostly.